All right, so this is going to deal with section 4.2, part A. We're not going to talk about the top because the top is just review stuff. Instead, we're going to talk about filling out these tables. So what is a table? What is the point of a table? A table is a way that we can deduce values for a specific function. So you know how you've seen our Cartesian point system. Oops, that was a bad line. All right, you've seen our Cartesian point system. It looks like this. Right, you know the graph. But this is an alternate way to look at the graph. It looks kind of like a graph when set up this way. But if you notice, we're going to put something up here. We'll call this x and this y. This is going to determine our values for our whole set. It can be used to determine any value on this point that crosses this line. Now, this may not look like a line at first glance, but it's actually a line in what we call standard form, which is ax plus by equals c. You're probably used to seeing y equals mx plus b. We call that slope intercept. But again, this top one is just called standard form. So that's how you're going to know how to tell the difference. So first off, we're taking this problem from number 16. Right here, we just pick three numbers wherever we want on the graph and make a table out of it. This will help me discuss tables. This will help me discuss graphs. I'm actually going to pick four numbers. I'm going to pick 0, 2, 1, and 2. I'm going to put them over here for a specific reason, and we'll talk about that. This table should then have values that fall like this. So it should be able to put a line across like that, a line across like that. So this should allow us to, man, I can't get what I want. Oh well. So that's 1. I'll rewrite it. This is 1. All right. So this should allow us to use this equation. First off, we take this and we say 0. So 0 is going to be plugging in for x. Whatever is right here will be plugged in for x. Whatever is right here will be plugged in for y, and that's how it's going to go the whole time. That's how we're going to do it. Everything there is going to be for y. Everything is going to be there for the x value. So just so you know, that's where we have. So this number, this one right here, or this 0, I guess you could say this 0 is for an x. So when x is 0, we need to find out what y is going to be. So first off, we need to solve our equation so that y is alone. Otherwise, we're going to have a tough time. Because we're going to have to plug in y, solve for x. It just makes the whole deal crazy. So let's get our equation to have y alone. So our first one is going to be 6. So we're going to have to minus 6x. That's going to have to happen. So negative 5y equals 12 minus 6x. Then we're going to divide by negative 5. All right. So now we get 12, negative 12 fifths plus 6 over 5 x. All right. So y equals that. So this is going to be a very important step to mention is we have now y equals. This will allow us to solve for any x value by just plugging in our x and isolating that side of the equation. I'll show you what that means. If we're to take this, we're going to have a negative 12 over 5 plus 6 over 5. And instead of x, we're going to take and put this 0. So we're going to replace this 0 with x. That then gives us 0 right here and 12 fifths. So we end up with just negative 12 fifths in this case. So that's pretty cool. The zeros are nice. I like zeros. That's why I picked it. I picked 0 because it's an easy number to work with. Now let's do the next one. So that's the first example. Now let's do this next one. If we have 2, we have negative 12 over 5 plus 6 over 5 times 2. Now I'm going to give you a second to work this one out and see if you get the same answer as me. All right, I hope you had enough time to work that out. So what we're going to do is we're going to have this equal y, right? So we're going to find our y. So the first thing to do is multiply our 2 out. When we multiply our 2 out, remember it's over 1, and we multiply straight across. So we get 12 over 5 minus 12 over 5. But plus in there, there's a plus in there, sorry. Okay, so that's what we have so far. Well, I see something. When we add these together, a negative plus a positive that's the same number equals 0. So in this case, y happens to equal 0. Well, that's cool. I picked a good number then, huh? So that's something interesting to note. That in this case, y happened to equal 0 when x was 2. But when x was 0, it didn't equal 2. Let's look at this on the graph and see what it looks like. So we're going to do it this way. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. All right, so this first point says 0. When at 0, y is negative 12/5. So it's down 2 and a little bit. So our y is right there on that one. It's down like 2 and 2/5. It's right there. This is equal to 2 and 2/5. And then there's 0. So x is 0. We stay on the y line. Then we go down 2/5. Now when y is 0, x is 2. Or when x is 2, y is 0. So that means that we're going to go over 2, and our point's going to be right there. Because that's over 2 up 0. So that's right there. Do you see how we have a line forming? Oops, I somehow got rid of my point there. Okay, so our point is there. We have a line forming because of those 2 points. So now we can continue to make points, and they will fall along this line. That's how it works. They will happen to fall along this line. So let's see. But these next points are a y value. That's going to make it tough if we try to plug into our equation. Because our equation is meant for x values. Remember how we solved for y? It's meant to put x values in to find a y. So why don't we do this? Why don't we change the way our equation looks? And I hope you understand this. So if you don't understand how to plug in x's, go back to the beginning of the video and watch it again. Right now I'm going to switch gears on how to plug in y's. So we're going to do it this way. So we're going to solve for x this time. We're going to say that this is going to be plus 5y. And then we're going to, now that we have that, we have 6x equals 12 plus 5y. Divide by 6. And we get x equals, that's 2, plus 5/6 y. All right. Now we're going to solve this for its values. So let's take our value here. Our first value is 1, so we're going to say this is x equals 2 plus 5/6 times 1. So I used 1 very specifically because 1 is a nice number. So I chose that because I know for a fact it's going to produce a nice number in this equation. So I said, okay, this is going to be multiplied by that. That's just 5/6. So 2 plus 5/6 is 2 and 5/6. We can go into the math behind it, but if you trust me, a whole number plus a fraction is always just the whole number and the fraction put together. It's just how it works. And I don't have really the time to explain it in this video. But we know that x is going to be 2 and 5/6. So that's 2 and a lot. Or 2 and a little bit, I guess. So we go over 2 and a little bit and up 1. And look, it's on our line. Crazy, huh? We expected it to be on our line. Because this line contains all the points contained in this equation that make it true. Every single point that makes this equation true, the 6x minus 5y equals 12 will be true for every point on this line. And that's why we have lines. They're produced this way. These forms are just ways of describing a line. Remember standard form and slope-intercept form. So let's do this final one, and I'll give you a couple seconds to see if you can solve it without me. And then we'll work. Remember, our equation is x equals 2 plus 5 over 6y. Okay, now that you've had some time to work that out, let's take our equation. But remember, we're not putting y in. We're putting in 2. So now we're going to take this, remember it's 2 over 1, we're going to multiply straight across. This becomes 2 plus 10 over 6, or 5 over 3. So if that's 5 over 3, when we add a whole number to the fraction, right, we can just add those, or we can do it another way. So this is going to equal 2 or 3 and 2/3. And I'll show that it works that way. So this right here, we need a 3 on bottom in order for it to work. We need to multiply that out. We get 6 over 3 plus 5 over 3 equals 11 over 3. 3 goes into 11 3 times with 2 left over, so we get 9 and 2/3. Or not 9 and 2/3, 3 and 2/3. And that equals exactly what I said it would. But that's how I proved what mine would equal before. But, so, you should have got 3 and 2/3, and if we go over 3 in a little bit, so 3 and a little bit right here, and up 2, we get right here on my point system. See how that's on our line? This will prove true for every point we plug in and we solve correctly. It'll work. That's why we create these tables. I'm going to make another video on some more stuff about this, but this is one facet of tables that I hope really helps you solve these equations.